Hello everyone. In this video, we are going to learn a chemical reaction and equation for grade 10, CBSE 10 as well as SSLC. So, before starting the chapter, we are going to learn all the important formula, how to write chemical formula. If you know how to write chemical formula, then only this chapter becomes easy for you. So, I have taken a few examples, okay, few chemical formulas which is which will be used for this reaction, this chapter. Okay, so before learning this, you should note down important ions with their symbols and valencies. So you can see here these are the frequently used ions in this chapter, like sodium Na plus and valency is 1, magnesium Mg2 plus valency is 2, potassium K plus valency is 1 plus 1. Okay, copper. Copper has variable valency 1 and 2. So Cu2 plus 1 or Cu2 plus. Okay, so plus 1 for Cu2 plus and Cu2 plus for 2 valency. Similarly, so less valency is called as As and more valency is what? Ik, like cupric. So 2 plus 2 will use. Q plus will use plus 1. Similarly, iron. The symbol is what? Fe2 plus and Fe3 plus. Okay, Fe2 plus means ferrous. Fe3 plus means what? Ferric. Similarly, zinc Zn2 plus valency is 2. Calcium Ca2 plus valency is 2. Hydrogen H plus valency is 1. Sulfide S2 minus valency is 2. Oxide O 2 minus. Okay, valency is 2. Chloride minus valency is 1. Bromide minus Br minus valency is 1. So generally positive ions are what? Cations and negative ions are what? Anions. Okay, we learnt in the 9th grade, right? And apart from this, you should know some radicals name also. Okay, like hydroxide OH minus valency is 1, nitrate NO3 minus. Okay, so valency 1, carbonate CO3 2 minus valency is 2, sulfate SO4 2 minus valency is 2, ammonium NH4 plus valency is 1, hydrogen carbonate or bicarbonate HCO3 minus valency is 1. Okay, so let's learn first how to write the chemical formula. I want to write a lead. Lead is what? Pb. Okay, plus 2. Plus 2. And nitrate is what? NO3 minus 1. So just 2 will come here and 1 will move here. Right now? So it is what? Pb NO3 whole twice. Okay, let's take some other basic first. Okay, like let's take sodium oxide. Okay, let's talk about sodium oxide. Okay, first you learn how to write sodium oxide. First of all, you should write the symbol. Okay, symbol of sodium is what? Na, oxide is what? O. And below we are writing their valencies. So valency of sodium is what? 1. Oxygen is what? Oxide is what? 2. So then we have to do crisscross. Okay, this is crisscross method. You can see. One will go here, one will 2 will move here. Right now, so we can write Na2O. Sodium oxide. This is sodium oxide. Okay, let's talk aluminium chloride. Aluminium chloride. Aluminium chloride. So first of all, we are writing the symbol. So Al. Okay, chloride Cl. Below we are writing the valency. Aluminium valency is 3. Chlorine valency is 1. Then crisscross method. So 1 will move here, 3 will move here. So 1 generally we are not writing. So it is what? AlCl3. Is it clear? Okay. Let's talk about magnesium oxide. Magnesium oxide. Very important chemical. Okay. So magnesium, how we are solving the magnesium symbol is Mg. Oxygen symbol is what? Oxide is what? O. And valency of magnesium is 2. Oxygen is also 2. If the valencies are equal, we can cancel. 2 1 ja, 2 1 ja. Right now, so Mg1 O1. 1 we are not writing generally, so MgO. Is it clear? Please make a note of this. You should practice. I am going to write the formula of all the compounds. Compounds may be ionic compounds or covalent compounds. Ionic compounds means generally formed by the transfer of electrons. Whereas when we talk about the covalent compound, which is formed by the mutual sharing of electron, like hydrogen sulfide, okay, methane, water. These are what? Covalent compounds. Ionic compound like sodium chloride, aluminum chloride, magnesium chloride, okay, sodium oxide. These are what? Ionic compounds, which is formed by the transfer of electron. We will learn these in metals and non-metals in detail. Okay, here we will focus first. I I'm going to write all the formulas here. Lead nitrate, as I told you, Pb, okay, Pb, okay, 2 plus is there, nitrate, NO3, minus is there, so this cross if you do, so we are going to write Pb, NO3, okay, whenever 2 moves are, it will go with the, we have to write in bracket, Pb, NO3, okay, Pb in bracket you should write 2, so NO3 in bracket, okay. Similarly, calcium carbonate, Ca, okay, 2 plus, carbonate, 2 minus. So plus 2 minus 2 get cancelled, so we can write CaCO3. Next up, magnesium oxide, just now we did a MgO. Magnesium hydroxide, see magnesium is Mg, okay, 2 plus hydroxide is what? OH minus 1. So we are going to write a 2 will move here, right? 1 will come here. So MgOH twice. Now barium chloride. So barium is what? A Ba. Okay, valency is actually 2. Chloride is what? Cl. Valency is 1. Yes or no? So this is what? A BaCl2. Barium chloride. This is fifth one. Next sixth one. Aluminum chloride we have done just now. AlCl3. Seventh one is barium sulfate. Ba 2 plus sulfate SO4 2 minus. So plus 2 minus 2 get cancelled. This is what BaSO4. Is it clear? Next iron sulfate. Similarly, iron is what? Fe 2 plus, sulfate is what? SO4 2 minus. So plus 2 minus 2 get cancelled. So it is what? FeSO4. You can write below also and you can solve, not an issue. Okay, sodium chloride. Sodium is what? Na plus 1, chloride Cl minus 1. Yes or no? So it is what? NaCl. Okay, that is a common salt. Okay, copper sulfate. Copper sulfate is what? Cu 2 plus, SO4 2 minus. Okay, so plus 2 minus 2 get cancelled. Is what? CuSO4. It is a blue color solution. Yes or no? Potassium nitrate. Potassium is what? K plus, nitrate is what? NO3 minus 1, right now. So formula is what? KNO3. Okay. Zinc oxide. Zn, zinc, Zn 2 plus, oxygen 2 minus, right now. So it is what? ZnO. Okay, these are the chemicals which will be used in this chemical reactions and equations. So you must know and practice once. Then the chapter becomes easy for you. Now let's start the chapter. Okay, chemical reaction. What do you mean by chemical reaction? When we talk about chemical reaction, it is a chemical change, yes or no, in which new substances are formed, okay, with new properties. Okay, let's see the definition. It is a chemical process in which new substances with new properties are formed due to the rearrangement of atoms. Yes or no? So we are representing a chemical reactions in the form of an equation called as chemical equation. So it is a shorthand representation of a chemical reaction with the help of symbols, formulae of the substance involved in it. Okay, so you see a chemical equation can be represented in two ways: word equations and symbol equation. Word equation is like, suppose you want to write a burning of magnesium. Magnesium plus oxygen gives you magnesium oxide. Okay, so if you write in a word like magnesium plus oxygen gives you magnesium oxide, so this is the word equation. And symbol equation is what? We have to write the formula or symbol of the elements or compounds. Yes or no? So if any element is there, their symbol we have to write. Any compound is there, their formula we have to write. Like magnesium, what is the symbol? Mg. Oxygen, O2 combines actually, so O2, and that gives rise to magnesium oxide, MgO. MgO formula is what? Magnesium oxide. Yes or no? So this is what a symbol equation. The substances which are combined during the process is called as reactant, and the new substance which is formed is called as what? Product. I hope you understood. So reactants will be written, generally is written on the left hand side and product on the right hand side. Okay, and they are separated by arrow mark. Is it clear? Now they are asking one question: why we need to balance a chemical reaction? Okay, we need to balance a chemical reaction to satisfy the law of conservation of mass. This we have learnt in the 9th grade. What is law of conservation of mass? According to this law, during a chemical reaction, masses of the reactants are always equal to the masses of the products. Or in simple words, we can say mass can neither be created nor be destroyed during a chemical reaction. To satisfy this law only, we have to balance the chemical reaction. This question may be asked for 1 to 2 marks. Okay. So law of conservation of mass definition you can see. Skeletal equation: an unbalanced equation is called as what? A skeletal equation. So we need to, generally we write the balanced chemical reactions. Okay, in the exam also they will ask you to write the balanced chemical equations only. Okay, so what is a balanced chemical equation? When we talk about a balanced chemical equation, so here the number of atoms on the LHS and RHS, that is reactant side and product sides, are equal. Okay, na? You can see a chemical equation is in which the number of atoms of each elements on both the sides of the equations are equal. A chemical reactions in which the number of atoms of each elements on both the sides of the equations are equal, then it is called as balanced chemical equation. You can make a note of this definition if you want. Okay, let's take one example. Burning of magnesium only, Mg plus O2 gives you MgO. So we'll check first is it balanced or not. So Mg, magnesium is there and oxygen is there. Symbol is what? Mg and O. Yes or no? How many atoms are there? Magnesium 1, oxygen 2. On the right hand side, that is product side, you see Mg is 1 and oxygen is also 1 only. Oxygen is also 1 only. Okay, magnesium atom is balanced, but oxygen is not balanced here on the right hand side. So to balance this oxygen, we have to multiply by 2. So once you multiply, you have to multiply to the in the beginning only. Now if you count magnesium become 2 into 1. This is, you see, 1 is just 2 into 1. Magnesium become 2. Right now? Magnesium become what? 2 on the RHS, yes or no? Sorry, this is you can see here. First of all, you have written on the reactant side, magnesium atom is 1 and oxygen atom is 1. On the RHS, you see, magnesium atom, how much was there? How many atoms are there? Magnesium atom. In the beginning, RHS 1 only, oxygen also 1 only. Now, what is not balanced? You can see oxygen is not balanced on the right hand side. So, to balance the oxygen atom, you have to multiply by 2. Once you multiply by 2, you can see magnesium also 2 into 1. Magnesium also become, next row, I can write oxygen become 2. Okay, na? And magnesium also changes to 2 only. But if you see LHS side, magnesium is still 1, but oxygen is 2. So you have to multiply here also by 2. Yes or no? So when you multiply here by 2, so you will get magnesium here also 2 and oxygen is 2. Now you can see LHS and RHS, all the atoms are equal. Yes or no? Getting up? Now one question they may ask you for 2 marks. Okay, mention the characteristics of a chemical reaction. Characteristics of a chemical reactions, or they can ask you how can you say that chemical reaction has taken place. So by certain characteristics only we can say. There are basically 5 characteristics like a change in a state. State means solid to liquid, liquid to gas, like that. Change in color, change in temperature, evolution of a gas and formation of a precipitate. So these are the 5 characteristics of a chemical reaction. You can make a note of these also. 2 marks questions frequently asked in the board exams or your UT assessments. Next, in our syllabus we have basically 5 types of a chemical reaction. Okay, first one is what? Combination reaction. Next, decomposition reaction. Third one, single displacement reaction. Fourth one, double displacement reaction. And fifth one, redox reaction. So we are going to discuss in detail each type of reaction. Okay, with examples. Some differences also and some important questions also we are going to cover. First, we talk about combination reaction. Okay, when you hear the word combination, means what? Joining, yes or no? Or it is also called as synthesis reaction. So it is a type of chemical reaction in which 2 or more substances combine to form a single substance. Yes or no? So we can represent this as A plus B gives rise to AB. Okay, for example, burning of magnesium only itself, Mg plus O2, MgO. Yes or no? So to balance, you can see here 2 was there and you write 2 here. So 2Mg plus O2 gives rise to 2MgO. How many reactants are there? 2 reactants. How many products are? 1 product. That's why it is called as combination reaction. You can see the definition. It is a type of chemical reaction in which 2 or more substances combine to form a single substance. Generally, the combination reactions are exothermic reactions. Exothermic means what? Heat is released or energy is released in this process. Okay, like burning of coal, you see. When you C plus O2 gives rise to CO2 plus heat. Yes or no? Next, decomposition reaction. It's very, very important. topic. Okay, it is a type of chemical reaction in which a single substance breaks into two or more simpler substances. It is the opposite of combination, we can say. And the nature is what? Endothermic reactions, in which energy is absorbed. Okay, energy in the form of electricity, light, or heat is absorbed. Okay, so you can see the definition. It is a type of chemical reaction in which a single substance breaks into two or more simpler substances. It is generally endothermic reactions. We can represent this as AB gives rise to A plus B. How many reactant? One reactant. How many product? Two product. Okay. For example, you can see electrolysis of water. Okay, whenever electricity is passed through water, 2H2O, which is in liquid state, will give you water, 2H2, hydrogen gas and oxygen gas. How many reactant? One reactant. How many product? Two products are there. So number of product is more in decomposition reaction. Am I clear? Decomposition reactions can take place with the help of heat, light and electricity. That's why there are three types of decomposition reaction: thermal decomposition, electrolytic decomposition and photochemical decomposition. Yes or no? Here the differences, they may ask you combination and decomposition. You can write it is a type of reaction in which two or more substances combine to form a single substance. Here ulta, it is a type of reactions in which a single substance breaks down into two or more simpler substance. Okay, it is represented as A plus B gives rise to AB. Here it is represented as AB gives rise to A plus B. One example you can write. And generally combination reactions are exothermic, whereas decomposition reactions are endothermic. Now types of decomposition, as I told you: thermal decomposition, the type of decomposition which takes place with the help of heat. For example, decomposition of lead nitrate. Okay, so whenever 2PbNO3 is heated strongly, it will give you what? 2PbO plus 4NO2 plus O2. This is very important reaction. PbNO3 is what? Lead nitrate. Okay, so lead oxide, yellow color residue you will get. Along with that, brown fumes of nitrogen dioxide you will get, along with oxygen. Photochemical decomposition, it is a type of decomposition which takes place with the help of light. Okay, for example, decomposition of silver chloride, AgCl, in the presence of sunlight gives you what? 2Ag plus Cl2. Even decomposition of silver bromide. Okay, we can write 2AgPr. Okay, in the presence of sunlight. Sunlight we can represent H nu, or you can write sunlight. H nu is the energy of sunlight. It gives you what? 2Ag plus Br. These two reactions are also used in black and white photography. Black and white photography, important questions. Next we have a electrolytic decomposition which takes place with the help of electricity. Okay, decomposition of water, 2H2O, when electricity is passed, it gives water, H2 gas and O2 gas. Okay, these questions are important, right? Any two observations whenever iron sulfate is decomposed. Iron sulfate is a water, white powder actually. Okay, so once you heat, okay, it undergoes thermal decomposition. It will give you what? Fe2O3 plus SO2 plus SO3. So brown color iron oxide is obtained. Along with that, burning a smell of sulfur, that is pungent smell. So these are the observations on heating iron sulfate. Equations are very important. 2FeSO4. Okay, this is the symbol of heat. Upon heating, give you what? Fe2O3 plus SO2 plus SO3. Okay, just now we discussed that observations for the decomposition of lead nitrate. So this is lead nitrate. So you can write the observations. Yellow residue of lead oxide is obtained. Along with that, brown fumes of nitrogen dioxide. Yes or no? Next, give two example of reactions. Okay, which is used in black and white photography. This is also textbook questions, important questions. Decomposition of silver chloride and decomposition of silver bromide in the presence of sunlight. Okay. Now, let's talk about a single displacement reaction. Okay, when we talk about single displacement reaction, it is a type of reaction, okay, in which a more reactive element displaces a less reactive element from its salt solution. Okay. So the condition should be there. Generally, a more reactive element will displace a less reactive element. See the definition. It is a type of chemical reactions where an element reacts with a compound and takes place the another element in that compound. Okay, you can see here equation example. Reaction of zinc with copper sulfate. Whenever zinc react with copper sulfate aqueous solution, see what will happen? Zinc sulfate plus copper is formed. So here zinc is more reactive than copper. That's why zinc will displace the copper. Okay, from its aqueous solution. Yes or no? So zinc metal plus copper sulfate give you zinc sulfate plus copper. Here next iron plus copper sulfate. Okay, copper sulfate is generally blue color. So whenever you add iron filings to the copper sulfate solution, you will get a green color of iron sulfate. Okay, along with the copper is obtained. Here the color is what? Blue to colorless. Zinc sulfate colorless solution. So I have covered here reactivity series also, which is there in the third chapter, metals and non-metals. What is reactivity series? It is the arrangement of elements in their decreasing order of reactivity. So from most reactive to the least reactive, a series of elements are there like a potassium, which is most reactive, then sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, and platinum. So once you move up from potassium towards gold, the reactivity decreases. Yes or no? So suppose when we talk about zinc and copper, which is more reactive? Obviously, zinc is more reactive. Okay, iron and copper, which one is more reactive? Iron is more reactive. Yes or no? So reactivity series are also called as activity series. Okay, you can see whether this reaction is possible. Lead, okay, plus copper chloride. Okay, so lead is here right now. Copper is here down in the reactivity series. So as lead is more reactive than copper, yes, this reaction is possible. So it will form lead chloride plus copper. Lead chloride plus copper is obtained. Now we talk about a double displacement reaction. Okay, what happens in double displacement reaction? It is a type of chemical reaction in which mutual exchange of ions take place. Generally, two compounds combine and gives another two new compounds in the double displacement reaction. So let's see the definition. It is a type of chemical reaction in which two different ions or group of atoms in the reaction molecules are displaced by each other. So it is generally two types of neutralization reaction and precipitation reaction. What is neutralization reaction? It is a type of reaction in which an acid reacts with a base to form salt and water. Okay, so you can see like sodium hydroxide, which is a base, react with hydrochloric acid to form NaCl plus H2O. You can clearly see sodium comes here and H comes here. So mutual exchange is happening. So NaCl is formed and H and OH will form H2O. That is neutralization reaction. When we talk about the precipitation reaction, it is a type of double displacement reaction in which an insoluble solid precipitate is formed. So precipitate is what? An insoluble solid. This is called as precipitate. So we can see the definition. When on mixing two solutions of ionic compounds, an insoluble solid is formed that separates out the insoluble solid formed is called as precipitate, and the reaction is called as precipitation reaction. Let's take this example. Reaction of barium chloride with sodium sulfate. Okay, you can take two test tubes actually. A and B you can mark. In that first test tube you can put a barium chloride, pinch of salt and take 10 ml of water. Make a solution, you will get colorless solution. Similarly, another test tube, you add pinch of salt, sodium sulfate, add 10 ml of water, make a solution, you will get a colorless solution. Once you add, you will get a white color precipitate, which is nothing but barium sulfate. Along with that, NaCl is obtained. Yes or no? Another equation you can see, lead nitrate solution, which is a colorless solution, potassium iodide solution, which is a colorless solution. Once you mix this solution, it will give you yellow precipitate of lead iodide. Okay, so plus KNO3. So PbNO3 whole twice aqueous, 2 Ki, that is potassium iodide aqueous. Okay, in whenever they undergo double displacement reaction, so PbI2, that is lead iodide is formed, which is yellow color, plus 2 KNO3. So what is happening? You can see here lead moving here, okay, potassium coming here right now. So PbI2 is formed, lead iodide, and KNO3 is obtained. Yes or no? Now, try to understand redox reaction. As the name suggests, redox, it is made up of two words, reda and ox. Red for reduction and OX for oxidation. It is a type of reaction in which both oxidation and reduction takes place simultaneously. It is called what? Redox reaction. So what is oxidation? What is reduction? That you should understand. Oxidation is nothing but the addition of oxygen or removal of hydrogen or loss of electron or increase in oxidation state. So this is there in higher standard. At least if you focus these two, enough for you. Okay, first three you should know being a good student. Like C plus O2 gives you CO2 oxidation. Twice of Hi gives rise to H2 plus I2. You see, with iodine hydrogen is there, here with iodine hydrogen is not there. So there is a loss of hydrogen. So it is oxidation. Okay, sodium having atomic number how much? 11. Z is equal to what? 11 atomic number. Electronic configuration 2, 8, 1. To become stable, it is losing one electron, becomes what? Na plus 2, 8. Yes or no? So there is a loss of electron, that is what? Oxidation. Reduction ulta. Removal of oxygen. Okay, like H2O giving rise to H2 and O2. You can see here, with hydrogen oxygen is there, with hydrogen oxygen is not there. So what is this? Reduction. Or addition of hydrogen. N2 plus 3H2 gives rise to NH3. With nitrogen, hydrogen is not there. With nitrogen, here hydrogen is there. So there is a addition of hydrogen. That's why it is what? A reduction. Or gain of electron. You can see chlorine atom having 17 electrons. Electronic configuration 2, 8, 7. To become stable, it gains one electron. Okay, yes or no? And forms Cl minus ion. So gain of electron is what? Oxidation. Yes or no? Now see this equation of redox reaction. Okay, zinc oxide plus coke gives rise to zinc plus carbon monoxide. You can see here C2CO. There is addition of oxygen right now, so this is what? Oxidation. And zinc oxide to zinc. Okay, with zinc here oxygen is there, here with zinc oxygen is not there. So there is a removal of oxygen, that is reduction. So in this reaction, both oxidation and reduction is taking place. Another equation you can see Cu2O plus H2 gives rise to Cu plus H2O. You can see here Cu2O to Cu. There is a removal of oxygen, that is reduction. And H2 to H2O, there is a addition of oxygen, that is what? Oxidation. So example of redox reaction. They may ask you to identify the oxidizing agent and reducing agent. You should remember one thing, the substance which undergoes oxidation is reducing agent and the substance which undergoes reduction is oxidizing agent. You can see here in this case, coke is undergoing oxidation. Yes or no? So coke is reducing agent and zinc oxide is undergoing reduction. So zinc oxide is what? Reducing agent. Sorry, oxidizing agent. Zinc oxide is what? Oxidizing agent. So you can see the definition. The substance which undergoes oxidation during a redox reaction is reducing agent. Okay, in this case, coke is what? Reducing agent. Oxidizing agent, the substance which undergoes reduction during a redox reaction. Okay, like copper oxide to copper. You can see this is a what? A reduction. Loss of oxygen. So this substance is undergoing reduction. So it is what? Oxidizing agent. Next, we talk about corrosion. What is corrosion? Next topic. It is the process of destruction of metal surface whenever it is exposed to moisture, air, acid, bases, salts. For example, rusting of iron, corrosion in silver, corrosion in copper. Okay. So here we have an example of rusting of iron. What is the equation? Iron react with oxygen and water. In the hydrated form, we form hydrated ferric oxide, Fe2O3 dot XH2O. Okay, I'm writing the equations once again. You can see here. Iron react with oxygen plus water. This will come from moisture. It will give you what? Fe2O3 into XH2O. This is hydrated ferric oxide. What is the hydrated ferric oxide? Ferric oxide. This is the formula for rust actually. If you want to do the balancing, so what you can do, here iron is 2, multiply by 2, yes or no? And one more thing, you can make it even. See, oxygen is here 3, here is 2. So first you make it even. Okay, na? So multiply by 2 here. So oxygen becomes 6. 3 to 6. Then you multiply by 3. Now 2 to what? 4. Iron is what? 4. What about water molecules? X into 2. 2x is there, so you multiply here by 2x. Okay, now, so this is a coming from moisture. So this is the formula for rust and this is the balance equation, rusting of iron. Okay, brown color is obtained. Similarly, we have a corrosion in copper. Copper will react with oxygen, water and carbon dioxide. It will be what? Basic copper carbonate. CuOH twice into CuCO3. Okay, this is a green color. Similarly, corrosion in silver. Silver articles, okay, will react with hydrogen sulfide, which is present in very trace amount in atmosphere. It will give you what? Ag2S, and black coating is obtained of silver sulfide along with the hydrogen gas. Is it clear? So we can prevent corrosion by certain methods are there. Painting, oiling, okay, greasing is there. Galvanization, what is galvanization? The process of coating a layer of zinc on iron articles. Okay, so that is what how we can prevent. The last topic is what? Rancidity. When we talk about rancidity, okay, it is a process of oxidation of oily and fatty food items, which results in their bad smell. You have observed that cooked chickens, muttons, or chips items, if you leave it for few days outside, so some bad smell will start coming out of it. It is due to the oxidation of fatty acids present in them. So we can see the definition. The process of oxidation of oily and fatty food atoms which result in their bad smell is called as rancidity. Equation also we can write in this form: oil or fat plus oxygen give you what? Rancid product plus rancid product only. This one. How we can prevent the rancidity? This question may be asked for 2 to 3 marks. There are certain methods, okay, by which we can prevent this rancidity. First one, by flushing with nitrogen. So you can see the chips packet, Lay's, Kurkure packets is flushed with nitrogen gas. Okay, now. So in the presence of nitrogen, oxidation cannot take place. Next, by using a refrigerator. Okay, at low temperature, what happens? The oxidation can be prevented. Next, by vacuum packings or airtight container. You can see whenever the oil or ghee is packed, so it is packed in a airtight container. Vacuum packing is there. Okay, and next is what? By using antioxidants. Chemicals are there. The help of that, we are preventing the rancidity like a BHA, BHT. I hope you understood this chapter, chemical reactions and equations. Okay. If you have understood, please like the videos, share with your friends, and don't forget to subscribe the channel. Thank you.